Alright, we are recording. Today we are doing questions 3 and 4 of 2018. Alright, so let's go ahead and jump on into it and see what we got. The first inactive question here, it says the graph of the continuous function g, and it says that is the derivative of f. So it says that g is f prime. Cool. It is shown above. And the function g is a piecewise function between -5 and 3 with linear functions, and we can see that. And then from 3 on, it looks like that it is the function, a quadratic function, 2 times x minus 4 squared. Okay. Now, it says in part A, if the initial condition, if f of 1 is equal to 3, so here we are, f of 1 is 3. Then what it wants me to do is figure out what the value of -5 is, -5 being right here. Okay. So remember how this works. All we got to do is take our initial value 3 and go plus the integration from 1 to -5 of f of x dx. That's it. So we start from our initial and we do the integration to get back. And I said f of x dx, I meant f prime of dx. So all I gotta do is just take the area underneath the curve from 1 to -5. But I'm gonna go ahead and rewrite this as 3 minus the integration -5 to 1 of f prime of x dx. Okay. Simply, all we have to do is find the area underneath the curve from this, from -5 to 1, and then do 3 minus that. Okay. So it looks like we got this, like from -5 to -2, it looks like we got this rectangle here, which that's a 3 by 3 rectangle, so that makes that 9. Okay. Then it looks like we got a triangle here. It looks like it's got a length of 3, a width of 1. Oh, and that's -9. I apologize because we're below the x-axis. And this is going to be negative, it looks like 3/2, I think. Okay. We don't have an area right here between -1 and 0 because it's just, well, it's flat. And then we got this triangle right here, which looks to be 2 times 1 divided by 2. Looks like that's going to be 1. Okay. Why does it do that? 1. So this is going to be 3 minus the quantity, -9 minus 3/2 plus 1. Okay. Now, this is a Calc inactive problem, so if I were you guys, like, I would leave it in this form here. That's perfectly acceptable. Otherwise, you can simplify it. It's going to be, let's see, 3 minus, let's go ahead and say, I said -16 over 2 minus 3 over 2. It's -8. So I did -9 and 1 is -8 and change that to -16 over 2 so I can combine like terms. And this ends up becoming 3 plus 19 over 2. And that ends up being, for a final answer, if you wanted as one quantity, 25 over 2. But honestly, I would leave it as the first circle there if I were y'all, but there's just the final answer if you wanted to simplify it down all the way. Okay. All right, now B says evaluate the integral 1 to 6 of g of x dx. Well, this is the g of x is just this graph, so this is the same thing as saying the integration 1 to 6 of f prime of x dx, right? Which is just going to be the area underneath the curve from here to here. Okay. Now it looks like we can break this into 2 parts. Like, I can find the area underneath the curve of this piece right here. This is just a square. But then in order to do the integration from 3 to 6, it's no longer like shapes I can find the area of. I'm going to have to use the integral of this function here. So I'm going to rewrite this as the integral 1 to 3 of g of x dx plus the integral 3 to 6 of g of x dx. Okay. Now I know this quantity right here is just the area of this square, which is 2 by 2 is 4. So it's going to be 4 plus, and then the integral 3 to 6 of 2, which I'm going to go ahead and take the 2 out, times x minus 4 squared dx. That's it. So it's the area of 4 and then plus that integral from 3 to 6. Okay. Which if I integrate this is going to be 4 plus 2. Now the integral of x minus 4 squared is going to be 1/3 x minus 4 cubed. Just doing power rule there, right? And this is going to be evaluated from 3 to 6. Okay. Nice. So I'm going to finish this up here. So I'm going to say this is 4 plus, I'm going to say 2/3. I'm going to go ahead and bring the 1/3 out and say 2/3. And then in my brackets here, I'm going to plug in 6. Which if I plug in 6, that's going to be 6 minus 4, which is 2 cubed, so 8. And then minus is going to be 3 minus 4, which is -1 cubed, which is -1. And there you go. If I were you guys, I would leave it in this form, or if you could even kept it as like, you could have just kept it as 6 minus 4 cubed, and then minus 3 minus 4 cubed. I just went ahead and simplified that down a little bit, but I would leave it in this form. Otherwise, you could say it's 4 plus 2/3 times 9, or 4 plus 6. I believe that's what that is, and that's equal to 10. So you can simplify it all the way down to 10, but that first circle is fine. Okay, but you at least have to do, you at least have to plug in the 6 and the 3. Okay. All right, let's move on to C. C says between -5 and 6, my entire interval on the open interval, if any, is there a, it says if any, is the graph of f both increasing and concave up? Okay, remember the graph we're given is G, which is f prime. So it wants to know, is the graph of f both increasing and concave up, and give a reason for your answer. Okay, let's talk about the reason first. So in terms of f increasing, that's whenever your derivative is positive. Okay, when your derivative is positive, your function's increasing. So I'm going to say this occurs when, and remember, we got to describe it in terms of the graph given, which is g. So I'm going to say this occurs when g of x, which equals f prime of x, and it's not by FTC part 1 or anything. They just told us that in the problem. But I'm going to say this occurs when g of x, which is equal to f of x, or f prime of x, is greater than 0. Okay. And, okay, how do I talk about concave up in terms of the derivative? Well, concave up is when the derivative is increasing. That's when your second derivative is positive. So I'm going to say, and when g of x, which equals f prime of x, is increasing. Okay, that is both whenever my function f is increasing and concave up. Okay, so on my graph that occurs right here. So there it's positive and increasing, and 4 to 6 it's positive and increasing. So if that's my derivative, that tells me that my function is both increasing and concave up. All right, so that interval is between 0 and 1 and 4 to 6. So that's my final answer. And if lastly in part D, it says find the x-coordinate of each point of inflection of the graph of G, and let's give a reason for our answer. So again, I always like to start with the reason. So what is a reason that f would have a point of inflection? Let's just go based off of definition. So f has a point of inflection when f prime of x, which is equal to g of x, okay, when goes from increasing to decreasing or decreasing to increasing. Okay, that is just definition of what a point of inflection is based off of your derivative. If your derivative changes from increasing to decreasing, so the point at which it changes from increasing to decreasing, if there is a point where that happens, or decreasing to increasing. Now this graph is a little tricky and annoying with this, so let's look at it. So it looks like we're flat, flat, flat. We're increasing, increasing, increasing. Okay. Now, I know a lot of people probably want to say that the point 3 is a point of inflection, but at this point, you have got to ask yourself, am I changing from increasing to decreasing? And no, you're not. Okay, you're changing from flat to decreasing. That is not from increasing to decreasing. Okay, over this interval here, you're changing from increasing to decreasing, but there's not a specific point at which you are changing that interval. The only specific point where you're changing directions is at x equals 4. X equals 4 is the only point on that graph where you are like instantly changing from decreasing to increasing. Okay, so so you only have one answer there. It's x equals 4. Okay. All right, here's our answer key. So let's see here. 2 points for the integral, which we came up with. All right, we said, well, we changed it to f of 1 minus negative 5 to 1 of g of x, which we came up with. It's okay if you leave your answer in this form here, but we got the answer down to 25 over 2. Ooh, look at this. They gave us a point in number 3 for splitting it at x equals 3, for saying like, hey, look, we know that this area is going to be 4, okay? And they want us to find this area by doing the integration of the quadratic function. You get a point for the correct antiderivative, which we did right here, and then a point for the answer, which if you left it in this form here, that's completely fine, or some derivation of that, but the final answer is 10. Okay. C, we get a point for the intervals, which was 0 to 1 and 4 to 6. And we gave the reason. It's because the derivative is greater than 0 and the derivative is increasing on those intervals. Okay. And then lastly in D, we get a point for the answer. So x equals 4 and a point for the reason. And that's the only point where we're changing directions, changing from decreasing to increasing. All right. And that does it for question 3. So let's move on to question 4. Question 4, chart problem. Yay, we like chart problems. So we had a graph problem and a chart problem, 2 very common types. All right, see these basically every year. All right, and this one's pretty straightforward, unlike that one we did yesterday with the what was it, with the escalator or something like that. I don't know. So those problems yesterday were kind of tough. These aren't too bad. Anyway, it says the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. All right, it's pretty straightforward. All right, we got 2 to 10 years here on the chart, and it's telling me the heights of this tree. Not bad. Select the values of the height are given in the table above. Use the data in the table to estimate h prime of 6, a very common part A question. And h of 6 is somewhere in between there. Using correct units, interpret the meaning of h prime of 6 in the context of the problem. So this is how you do it. H prime of 6 is approximately equal to, it's just average rate of change, right? So h of 7 minus h of 5 over 7 minus 5, which is 11 minus 6 over 7 minus 5, or 5 halves. And the measurement, or the units, are meters per year. Okay. So there it is. And if I want to interpret this in the context of the problem, remember we're just the derivative is an instantaneous rate of change. So we're just going to say at a height of 6. So at h equals 6. Oh, I'm sorry. This is in terms of time. What am I saying? I apologize. At time equals 6 years, the rate at which the height of the tree is changing, so the rate at which we're changing is 5/2 meters per year. There's your interpretation. You need to have a rate in there, you need to have the time in there, and just talk about how it's the rate that it's changing and then put the units of measurement. Okay? Nothing too terrible about that, I don't think. All right, let's move on to B. B says, explain why there must be at least one time for which h prime of t is equal to 2. All right, we're given a chart, and we got to conclude that a derivative is equal to 2. What theorem do we do to talk about when a derivative equals a number other than 0? If it was 0, it would be Rolle's theorem. But if we're talking about a rate of change equaling another number, this is the mean value theorem. Okay? So we need to conclude that by finding 2 points, all right, 2 endpoints. Sometimes it's the actual endpoints, but we're going to find 2 endpoints where the rate of change is equal to 2. Now, looking at h's, or look at time equals 10 and 2, looking at those endpoints, it's not going to be 2. But how about in the middle here? If I found the average rate of change between those 2 points, which is on the interval 2 to 10, then remember that's going to be so h of 5 minus h of 3 over 5 minus 3 is equal to 2, right? It's equal to 6 minus 2 over 5 minus 3, which is 2. Okay, so if the average rate of change is equal to that, then there's somewhere in between those 2 points where the instantaneous rate of change must also be 2. So we found that interval. Okay, so we're going to do a since then statement here. So we're going to say since, okay, and we're going to say the requirements for mean value theorem, which the requirements are only that it's differentiable and continuous. Well, it tells me in the problem that it's differentiable. So I'm going to say since h of t is differentiable on the interval, and I'll go ahead and specify the interval 3 to 5. And you can include the endpoints there because it tells me that those points are twice differentiable. So I'm going to say since h of t is differentiable on 3, 5, and therefore, remember, differentiable implies continuity. So you can say since h of t is differentiable on the interval, and therefore continuous on the interval 3 to 5. So there's my since part. Then we can say, then by MVT, which if I was you, I would spell out, then by the mean value theorem, then we're going to say the conclusion. There must exist a value C, we're going to say on the interval 3 to 5, which I'll do the open interval, such that f, or I should probably say h, not f, such that h prime of c is going to equal 2. There you have it. There's our since, our then. We had the requirements. We had our conclusion on the interval. Everything worked out pretty good there. All right, that's 4b. Let's move on to 4c. It says trapezoidal approximation. We're good at this. It says use a trapezoidal sum with 4 subintervals. So there's 1, 2, 3, 4. Indicated by the table, by the data in the table to approximate the average height. Okay, the average height of the tree over the time interval 2 to 10. All right, average value. It wants me to know the average value. Average is equal to 1 over 10 minus 2 times the integral 2 to 10 of h of t dt. That's what it wants me to approximate. And it wants me to use a trapezoidal approximation for this interval. So this is approximately going to be equal to 1/8, and then the trapezoidal approximation. Okay, which, because we have different intervals of our heights here, I'm going to do 4 different trapezoid areas. So remember, the trapezoid is 1/2 height times base 1 plus base 2. So if I'm doing it for this trapezoid here, that's going to be 1/2. The height is the distance between 2 and 3, which is 1. Base 1 is 1.5, and base 2 is 2. Plus 1/2. The height between 3 and 5 is 2. and then the bases are 2 and 6 plus 1/2. The height between 5 and 7 is 2, and the bases there are 6 and 11. And then finally, 1/2, the height is 3, and the base is 11 and 15. Okay. And honestly, guys, Calc Inactive, if I was doing this exam, I would leave it that way and just go on with the problem and be done with it. But the answer key did go all the way, so I'll just show you that real quick. So it's going to be 1/8. I would simplify down each piece. This looks like it'll be 3.5 divided by 2, which is 1.75, plus that's going to be 8, I believe. Yep. Plus this is going to be 17, and this is going to be, that's 11 and 15 is 26, divided by 2 is 13, times 3 is 39. And if you want to leave it there, that's fine, but again, I'll keep going. That's 1/8. Let's see, 65, yeah, 65.75. And I would honestly leave it there, but they divided it by an 1/8 and they put it as a fraction as 263 over 32. But again, I would stop right there if I was y'all. Okay, so that just approximated the average height of the tree over the interval 2 to 10. Okay. And then lastly, D. D is a pretty good problem. It says the height of the tree in meters can also be modeled by no longer this function h of x, but by g of x, which it's no longer in an input of years. It says where x is now the diameter of the base of the tree in meters. So it's saying I can model the height based off of the diameter and not by the years. And it says when the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. Let's go ahead and classify that. Remember, x is the diameter of the base of the tree in meters. So this is saying the rate of the diameter changing. So this is actually talking about dx over dt, the rate at which the diameter is changing, which is x. And it says, according to this model, what is the rate of change of the height of the tree with respect to time? Well, remember that the function that models height is g of x, so this is asking for dg over dt. It wants to know the rate of the change of the height, which is g, in respect to time, so dg over dt. And it wants to know it whenever it's 50 meters tall, so whenever g of x equals 50, whenever the height equals 50, all right? So if I want to know what dg over dt is, I want to take the derivative of the function. So let's go ahead and start with taking the derivative of the function. And that's quotient rule, so I'm going to do low, which is 1 plus x, d high, which is going to be 100 dx over dt, low d high minus high, which is 100x, d low, which is just going to be dx over dt, all over low, which is 1 plus x quantity squared. Okay. All right, so I can simply find my answer, dg over dt, by plugging in all my values. So I have dx over dt as 0.03. The only thing I don't have, though, is what x is. I have what g of x is, but not what x is. So how can I solve for x? Well, how about just do, over here in the corner, 50 equals 100x over 1 plus x. It's telling me the height, but not the diameter. And I can just solve for the diameter by setting it equal to the height given, right? So if I solve that out, it's going to be 50 plus 50x equals 100x. If I multiply both sides by 1 plus x. And I get that 50 equals 50x, or x equals 1. So this is going to be the same thing as 1 plus 1 times 100 times dx over dt is 0.03 minus 100 times 1 and then times 0.03, all divided by 1 plus 1 squared. And honestly, guys, Calc inactive, maybe leave it that way. But it's not a bad one to simplify down, I don't think. Like, I'm going to do each piece right here. So this quantity right here, I'm trying to squeeze it in here. That's 2 times 100 times 0.03. So 100 times 0.03 is 3. 3 times 2 is 6. So this becomes 6 minus. And then 100 times 0.03 is 3. Over 2 squared is 4, which is 3/4. And that's meters per year. There you go. That was question 4. Let's look at the answer key. It says that, let's see, we get a point for estimating and getting 5/2, and 1 point for the interpretation, which we wrote out pretty similar. In letter B, we get a point for identifying that it's the interval 3 to 5 that gives me that 2. And then 1 point for the conclusion using the mean value theorems, like saying, okay, hey, I know between 3 and 5 that because it's continuous and differentiable, I can use the mean value theorem to guarantee a slope of 2 between those 2 points. Okay. 1 point for the trapezoidal sum and 1 point for the approximation. So 1 point for setting up the correct work, and honestly, if you leave it in that form, you're fine. D, you get 3 points. They set up the notation a little bit differently than we did, but this is essentially what we did. They just always take the dx over dt out. They factor it out, but we left it in there. So 1 point or 2 points for getting there, and then 1 point for getting the correct answer of 3/4, which if you just left it unsimplified, I'm sure it's fine. All right, well, that was questions 3 and 4. Good luck. If you have any questions, message me, and we will be in touch. So you can submit all the way through 2017 if you like. Otherwise, just keep working on these guys and get them submitted to me when you can. Y'all are doing an excellent job, so I appreciate y'all. And that does it. Goodbye.